Okay, ladies, it seems like we're pretty settled. We might as well get started. I want to introduce you to our special guest, Emily. Emily is a civil engineering major here at WVU. And today, Emily is going to be giving you guys a presentation on water filtration. So she's going to teach you how to clean water, as her presentation says, with dirt. So I'm going to hand it off to Emily, and everyone listen to her wonderful presentation.
Thank you so much for introducing me. Like she said, I'm Emily. It's nice to meet you all. Thank you so much for coming. I'm a civil engineer, and that means I cover everything from bridges, roads, but we also clean water. So the water that comes out of your tap at home and the water that you see running through rivers, we take care of that and we look at the quality of it. So let's look a little bit about how to clean that water with dirt. All right, so like I said, we use a lot of water. In America, we have really great access to water, and people use about 136 gallons a day. You can imagine a big gallon of water or milk. Just imagine 136 of those. How much of that is consumption? That's about 6 of them, and that also includes cooking, drinking. You use about 16 showers and baths. I know you guys probably don't because you're a little bit smaller, but I know adults, some of my friends like to take 40-minute showers, hour-long showers. Use a lot of water. Toilets, every time you flush a toilet, you use a lot of water. It's actually kind of crazy. We don't think about it a lot. And of course, outdoors, so if anybody has a pool or you like to go to a community pool, just imagine all of that has to be clean, it has to be fresh. You don't want to be going and using really stinky old water. So water is pretty important to us. Where do we get our water though? There's a lot of water on Earth. If you've been to the ocean, then you know, or you just look at a map, there's tons and tons of water, just as much as there is land practically. But how much of that is fresh water is only about 2.5%. So of that fresh water, which could be in ice, it could be in lakes, only about 1% of the fresh water is available for us to use. And so that could be all over the world. We have a lot of water in the United States. We've got rivers where we can get water. We've got reservoirs, which just hold water for us. But a lot of places don't have as much. Maybe they're more they're more dry, they're more hot, and so access to water is a little bit more tricky for some people. So where does water come from? Continued. Some sources of water include streams. Man-made sources of water include wells where we get water out of the ground from aquifers. And all of that water is what we're mainly using. We don't have any way to use seawater efficiently yet. There are some ways to take the salt out of seawater, but they cost a lot of money and they use a lot of energy. So right now, these are our main sources. So what's in that water? If you go out to your nearest stream or lake, you probably know that you don't want to drink straight out of it. Your parents tell you you don't want to because, well, there's a lot of nasty stuff that can get in there. So this image kind of shows just a few of the things that can cause some nasty stuff to get into our drinking water. And this includes surface water. Surface water is things in lakes, streams, and groundwater, again, like I said, is stuff underground in the rock, in the soil. So runoff from agriculture and pesticides. We need pesticides to grow crops efficiently, and runoff from all of that goes right into the water that we could be drinking out of, especially if you live in a very farm-heavy area. Gasoline leaks or any runoff from a city. If you're driving by a gas station, if any accident happens, all of that is going to go straight into the grass and straight into the water. Animal waste and dead animals, sounds kind of gross, but again, on farms and stuff like that, there's not really a good way to keep animals from, doing their business somewhere right next to a water source. So we have to worry about all of that, including other drugs and medications, flushing of water, sewage. All of that is the job of engineers and of scientists to take care of so that we can live healthy, good lives and not have to worry about, getting sick from our water. So how do we filter water? How do we get rid of all that nasty stuff? Or actually, I forgot this slide. Why does this even matter in the first place? Like I said, a lot of people have a lot harder time getting access to water. Imagine if you went to go turn on your tap and nothing came out. Imagine if you had to walk miles a day to go get water, or maybe you had better things to do, like going to school. If you spent all your time going to water, you wouldn't be able to go to school. So that causes a lot of problems, especially in other countries. We see it here in America in rural areas, but we see it a lot more in places most continents, but smaller countries. Unsafe water is responsible for 1.2 million deaths per year. It's a lot of people. 6% of deaths in low-income countries are the result of unsafe water sources, and 666 million, that's 9% of the world, still, like today, does not have access to an improved water source. 2.1 billion, 29% of the world do not have access to safe drinking water. Safe drinking water could mean it's too far away to go get, so you can't just walk to the kitchen and get it, you have to go walk for miles. It could mean the water is, if what's coming out of your tap is not good for you, if it's going to give you cancer or make you sick or a number of things, that's not safe water either. So we have to worry about this as scientists and as people that are interested in helping other people to make sure that, we can all live safe, healthy lives, not have to worry about those things. We have better things to worry about. So how can we treat water? You've probably seen a water treatment plant before, and if you haven't, maybe you've seen or driven by these places with big pools of water and you were kind of confused what they were. Those are basins for storing water in the first processes of treating it at water treatment plants. So those big basins essentially are used to, let water settle and let the sediments inside of it settle down. And then it's also used to do a number of chemical processes that make it more safe. That's a big scale though. So this water, you see, there's a lot in there, and it can treat for probably a whole city or a small town at least. But a lot of places don't have the money for that, and they don't have the infrastructure for that or enough money to build that. So a lot of places will also use instead of a small water treatment system. So like this one in the left-hand corner here, that's what we're going to be kind of building today actually, is a sand filter. And that can treat water for one household, one person, and it takes a little while, but it's really cheap to make, and it does a really good job, a surprisingly good job. So to wrap that up, treating water essentially takes raw water, which is water that you get straight from the ground, straight from the stream, and then we treat it with a number of different ways, and then you get drinking water. You're good to go. Sedimentation. I think I kind of talked about this a little bit. So it's when water sits still and the dirt in the water or anything that's making it cloudy, which is called turbidity, settles down, and you can remove the cleaner water on top. That's one of the processes that will happen in those big basins. To go back, these ones up here, that's just one of the things that happens. So once you've settled some of the water, another basic way to filter it or to clean it is filtration. What we're going to be building today is called a slow sand filter. There are also rapid sand filters, there are bio sand filters, and they have a bunch of different uses. So as you can see here, the water goes in from the top. That's that dirty water right there, it's all brown, and it goes through a biological layer. It goes through sand, gravel, and large gravel. And the water comes out of this pipe down here through pressure, and it's usable. These are used all over the world in places where they don't have enough money to build a big treatment plant or something fancy, or maybe there's not power. This doesn't take power to do. So if you don't have electricity and you need to treat your water, or maybe you don't have access to chemicals, etc., you can use this. So a little bit more about how it works is, like I said, the water comes down, and when the water first hits up right at this top layer here, the bacteria in the water and all the contaminants kind of stay there for a minute. And so when that happens, they are able to basically turn the harmful bacteria into something safe, something that, you know, wouldn't hurt you if you were to ingest it or eat it. So once it goes through there, the fine sand and gravel will just take out all of the more hard to get out things like mud, dirt, and a bunch of that. So I have a small video here to explain a little bit better because I know I'm not very good, and this will give a good visual. Let me make sure I am sharing audio. There we go.
This is the biosand filter, a unique Canadian invention that Samaritan's Purse Canada has been implementing for many years to save and improve lives all over the developing world. Inside this concrete shell are components that work together, using simple and natural processes to turn dirty, potentially deadly water into safe, drinkable water. How does the biosand filter work? First, pour water into the diffuser basin. It slows the rate at which the water falls onto the sand below, where the filtering begins. There are 4 filtering processes.
Hey, Emily, we can't see the video.
Rather than in a sequence.
You know what I need to do is share my screen instead of the PowerPoint. You know, as many times as I run Zoom meetings, I still don't learn how to do this right. All right, can you see the screen now? Thank you. Sorry about that, guys. All right, here we go.
This is the biosand filter, a unique Canadian invention that Samaritan's Purse Canada has been implementing for many years to save and improve lives all over the developing world. Inside this concrete shell are components that work together, using simple and natural processes to turn dirty, potentially deadly water into safe, drinkable water. How does the biosand filter work? First, pour water into the diffuser basin. It slows the rate at which the water falls onto the sand below, where the filtering begins. There are 4 filtering processes. They happen at the same time, rather than in a sequence. Together, they remove lots of organic material, worms, bacteria, protozoa, and viruses. Water flows down through the filter. The top 2 centimeters of sand catch organic material and organisms which build up over time. This organic material develops into an intensely active, complex food chain that digests the disease-causing parasites and viruses in the water. This area of the filter is called the biological layer. As the water flows further down, organisms become trapped in the fine sand. This filtering process is called mechanical trapping. The fine grains of sand also hold a static charge that causes some organisms to stick to the sand. This filtering process is called adsorption. The 4th filtering process is called natural death. As the water nears the bottom, there is very little lighter food, and so disease-causing contaminants naturally die off because they don't receive the nourishment they need to survive. When the water reaches the bottom, other water pushing down forces it up the riser pipe and out the spout. Almost all contaminants have been removed, making it safe to drink. Although the biosand filter looks simple, it's actually very sophisticated and effective. We've adapted the technology to create larger filters, what we call Samaritan filters, for providing safe water to schools and entire communities. Biosand filters and Samaritan filters won't provide safe water for very long if the people using them don't practice proper hygiene. And so health hygiene training, including stressing the value of hand washing and using latrines, are an important part of every filter we provide. Together, the filters, the training, and the latrines we provide are saving and improving hundreds of thousands of lives in the developing world every day. So help us turn on the tap to save water in the developing world. Donate towards Samaritan's Purse Canada's water projects at turnonthetap.ca or by...
All right. And we'll go back to the presentation. All right, so if you were paying attention, you probably realized that this filter treats, I should have put an option E, all of the above. It treats organic material, bacteria, E. coli, and cloudiness or turbidity. So like you saw in that video, these are really important for bringing water to people, or safe water, that don't have access to electricity. They're also good in emergency settings when the power goes out. All right. Oh, all right. So I'm actually gonna keep this on, or actually stop sharing so you guys can see me. This is my lovely apartment. And I have behind me the things to make a miniature sand filter. We won't be making one of the ones in the photo, although people at West Virginia University actually traveled to Nicaragua to build those themselves, which is kind of cool. I don't have one with me, but that was really neat. Back over here. So what I've got with me today to build this, and you can build all of this at home if you get your parents' permission. It's really easy. There's a couple parts of it where you just have to handle some sharp objects, so make sure somebody's with you if you do this. But it's really easy and pretty fun. So what I did was I took a giant water bottle, one of those really big ones that hold a lot of water, and I cut the top of it off. Just so that, you know, it's easier to pour water in. I could have kept the top on, but I thought this looked better. And I also poked a few holes in the bottom here. They're not very large, if you can see. Just little holes about the size of a pencil or a little less. We'll see how well this works. This is the engineering design process is trial and error. So if you've ever done a science project before and it didn't go your way, don't give up, because as we're going to see here, there's a number of ways to make this even better. So I've got the water bottle ready to go. This will be our filter base. I've also got, as you might guess, some sand. This is just playground sand. I got this at Walmart, and I spent maybe 10-15 minutes washing it out. So I put water in this big container, and it got really cloudy, and then I kept pouring it out and doing that over and over until the water ran mostly clear. So this sand's pretty wet still, but that shouldn't matter. Then we've got some gravel. I have two sizes of gravel here. I've got some really big rocks that I found just near my apartment, and I washed them all off, and I've got some smaller pieces of gravel too. You can find this in parking lots. You can find it really about anywhere that there's construction. Just make sure you're okay to take materials wherever you're trying to get some from. And like I said, make sure you wash it off really good, because this is just sitting around in somebody's yard or something. It's pretty dirty. Speaking of dirt, I have some dirty water that I'm going to stir up a little bit more to make it look even more disgusting. So I just took some mulch and some mud from outside of where I live and mixed it with some water. I try to make sure there's no chunks or anything. This is going to, we're just going to pretend that this is, you know, I'm going out to the stream, I'm trying to get some drinking water, but the water is absolutely disgusting and I don't want to drink it. It's going to show us how well this actually works, if it works, and then we'll see. Oh, one other thing that I have today here that I'm not going to add to my filter, but if you have a grill in your yard, or if you know your parents like to grill out sometimes, maybe like to have fires, you may have charcoal. So this charcoal comes in big rocks, and if you get your parents to help you, you can grind it up. You can grind it with either a bigger rock, or if you have a really strong like food processor or something like that. Don't break any of the equipment in your house. I didn't tell you to do that, but you can break up the charcoal to a powder. And charcoal is used in both water treatment plants and a number of other places to get rid of a lot of impurities. So you might know charcoal, and I think they make it, they put it in toothpaste sometimes now. They use it in, like I said, water treatment. A lot of water filters, small ones. I go camping, and so I have to filter water that I'm going to drink with. Those have charcoal in them. If you ever seen brittle water filters, I'm pretty sure they have charcoal or something similar in them. But yeah, that's another way that you can make this even better. I'm not going to add that today though, because I do not have a big rock or a food processor. And then I'm actually going to get a container real quick for clean water too. charcoal is dirty. How does it clean? So charcoal itself, that's a good question. Charcoal has properties which help it get rid of, I think, does it get rid of anything microbial or, I can't remember. Does anyone know this off the top of their head? I know that it has like properties that help it clean. I don't know exactly what it gets rid of, but anything is dirt at some degree. So as long as you wash off the charcoal so that water runs clear through it, it's not going to hurt you. It's completely ingestible. Some people eat charcoal on purpose as a vitamin, basically, or as a supplement, I mean. So good question, though. I wish I could answer it better. All right, I'll be right back. All right, so I've got a big container here. If I miss any questions in the chat or anything, feel free to interrupt me. I'd love to answer them if I can. But I can't see very well from here. I have bad vision. All right, so what I'm going to do to build this filter, as you guys saw in that picture earlier, they have the big rocks at the bottom. So we're going to take some of the larger pieces of gravel and put that.
We use charcoal as the rocks in the bottom.
We're going to put the rocks at the bottom, yes. The big rocks, not the little rocks.
Can we use the charcoal as the rocks if we don't have rocks?
I think you could, yeah. Just make sure you wash it off. Like I
Does
said,
it have to be the dust?
yes, it does have a lot of dust on it. It's easy to break.
Is it like, do we have to make it into the dust before we put it at the bottom?
You don't have to, no. So make sure you have a big chunky layer at the bottom so that it drains easily, so that water can come out. But when you use the charcoal, if you have a powder, you're going to want to put that either in the middle or at the top. Does that answer the question? That was a good one too. I'm being picky about my rocks that I'm putting in here. And you could also make this bigger too. If you have a big gallon jug like you saw in the picture earlier, you could use a gallon jug to make this. You could use a bucket. When Engineers Without Borders went to Nicaragua, they actually used buckets to form the flow sand filters. So next I'm going to go in with a layer of my smaller gravel. These are about, I don't know, blueberry sized, but it's really just what I have. If you use something else, it might work better. You guys are scientists. I expect you to go and experiment. You might find something new that works even better. And you'll have fun too. This is pretty fun. I mean, I'm literally just playing with dirt and rocks. So, mix up the water a little more. After that, I have my layer of sand here. I'm actually going to try and get some of the extra water off. This is playground sand. And I have a nice measuring cup too. You don't have to use a measuring cup. I just didn't want to get any of my spoons dirty. So, put this in here. Now in the video, it showed you that when you pour water in, it gets a biological layer on top. That's not going to happen for us probably because that happens over time. But if you were to use this filter for a long period of time, it would get a thin layer of biological material on top that would help filter other stuff, and it would react with the bacteria in the water. But yeah, this is what we've got so far. If it doesn't work very well, I might add more sand, but let's see. Actually, I think I am going to add more sand. This doesn't look like it's going to do enough. As you can see, the water is very gross. It is in fact working. I'm going to add more sand though. I'm going to add it slowly. In the video, they had this thing called a diffuser plate, and that just helps get rid or it helps slow down the flow of water, and so that it goes all the way over the surface of the filter instead of just piling on one location. All right. So far, it's a good thing I don't care about this table. Now, it's not perfect, but if you can see, I'll get our first sample out to show. Can't really see on Zoom very well, but it is dramatically better. And in this case, what are some ways that we can make this better? Does anybody have any ideas? We could do it more than once. Yeah, it does kind of look like sewage water. Again, I'm not going to drink this.
So how does mud and dirt clean water?
Can you say again?
How does mud and dirt clean water?
Oh, okay. So when the water goes through the mud and dirt, because this dirty water has a lot of mud already in it, right? So the particles of dirt are so big that they can get trapped in between the pieces of the sand, and they're trapped there. And so when the water keeps moving through, because water is smaller than the size of the dirt, the particles of dirt, the water goes all the way through and the water is clean. If there's any dirt in the water left, it means that we could use a finer sand. So if the particles in the dirt are really small and there's a lot of air or a lot of places for the dirt to move through with the water, it's not going to do as good of a job. So we could make the sand finer. It has smaller particles. Then we could also add the charcoal. How do I know it's safe to drink? This water probably isn't safe to drink, or I wouldn't want to drink it. It probably is safe, but when it gets purified. So there are a number of ways to test if water is safe to drink. You can test it chemically. You can test for bacteria in the water. And that's done by checking a number of different things. If you look at a small sample of water under a microscope, you can count the number of bacteria and you can see if they're harmful or not. You can look for how much turbidity or dirt is still in the water. If there's a large amount and that's measured in a specific unit that you might not have heard of yet, it's called normal turbidity units. Then if it's really clear enough, That's one of the things that makes it clean to drink. Another thing is pH as well. So pH is acidity, and it's measured on a scale, and you can get little test strips to test that. But yeah, that's how you know if water is safe to drink. And we do a pretty good job of testing before our water gets to us. If you don't know if your water is safe or if your water is definitely unsafe, you can also boil water to clean it.
Olivia, you have your hand raised. Do you want to ask a question?
Sorry.
No, I don't have a question, but maybe you could like run it through it again and again so that it can get cleaner and cleaner.
I like that idea. In fact, I think I'm gonna do that.
Because like when you did it the first time, it was cleaner, and if you do it again, it might be cleaner again.
That's a good point. All right. So
Nova, you also had your hand raised. Did you want to ask something?
No.
Adrian, do you have your hand up too?
Yeah. Where do you get the gravel? Because you paused.
where did I get the
when you
gravel?
said it. Mm-hmm.
So I went to a parking lot near me that's made of gravel, and I got different sizes. I shook it a lot. So when you shake a container full of gravel, the big pieces are going to separate from the small pieces, and you can just scoop them up. And that's how I got my gravel. And then I washed it again.
Okay.
Yeah. You can tell it's working because my filter here looks really gross now. You can't really tell because of the light, but it's filled with dirt on the very top layer. If this were being used in real life, you would want to clean your filter every once in a while. So you would want to scrape off the top layer, or you would want to replace it with new sand. But usually these have about a pretty good time for usage. Now, so that I have enough containers, I'm gonna go take this over to the sink really quick, or actually the trash can, and get rid of some of the extra dirt. All right, one more. On another note, this also doesn't smell very good, in case you guys were curious. All right. So here's our first sample. This is our first round of testing. It's already better, but let's see what happens if we try it again. I also have a second one, plastic container in here. You don't have to have that, but it helps me show you guys what's happening. So I'm going slow. It's pulling up in the middle. I'm going to move this in a little bit so it's even. It's working a little bit slower now. I think it's because a lot of the dirt got trapped like we saw before, because the dirt gets trapped in that sand. So the more we do it, the better it should work. And it's working really slow now. Be patient, we'll give it a second. This is like watching water boil. All right, I think that's about it. There's still some of it at the top. All right. Almost there. I should have brought some background music.
How does animals survive without water? They do not survive, but I know that that animals actually, some koalas drink water from that, and that's a way for koalas to survive.
You mean, how do animals drink the dirty water?
Well, I think that I have a hypothesis. Maybe the water was kept in the leaf so it didn't get dirty. Maybe that's why animals have it.
That's a good theory. I'm not sure. Animals also can't drink water with a lot of gross stuff in it. So if there's bacteria in the water, and animals are drinking out of the same source as humans, and the water isn't clean, animals will also get sick. But animals can't tell us that, so that might be. I don't know. All right, it's time for our second reveal. And I think your hypothesis was correct. I wish I had that first sample with me, because from the top of it, which actually I can move my computer, it is much better than the dark brown that we had earlier. And as you guys might have been able to see, and I should have brought my laptop a little bit closer so that you could tell, it moved a lot slower through the filter, which means it was doing a better job. It was having a lot more resistance to move through. So a lot of the color has gone. I still probably wouldn't drink this water, but it does show you that you can clean water with something that isn't just a filter that you bought at the store, or it isn't a chemical that you bought. Are there any more questions? All right, if not, that's all of my water filter build that I have today. And I will go back to my PowerPoint really quickly. All right, so this is what we built. All right, when do you use this? They showed you in the video a little bit, but we all go to West Virginia University, and our university had the great opportunity to send some students to go build water filters in another country. Providing safe water is something that we take really seriously at West Virginia, and I'm a part of a club here that actually goes and does projects just like this all over the world. One of them was in Nicaragua, and Nicaragua is a beautiful, beautiful country. A lot of people there don't have access to clean water though. Oh, do I have it? Sorry. All right. But yeah, so as you can see in this picture over here, this is one of the filters that we built. They were built in large containers. We also had some smaller ones that were built in buckets, but they had the same layers that you saw here, maybe a little bit different amounts of things. They also, I do believe, used charcoal for that, and they were used over a period of time. So these ones here in the picture, they got that biological layer that we saw at the very top. And this was used and still is used today in Nicaragua. We also have projects in other countries that use different methods to develop clean or give people clean water. So another way to clean water, if it's not really cloudy and there's not a lot of dirt in it, but you know, maybe there's E. coli, there's bacteria, there's stuff that can make you really sick or even kill you, but you can't just filter it out. In that case, we use chlorine. You know, chlorine from probably putting it in pools if you smell a really nasty chemical. But chlorine in very small amounts and bleach in very small amounts can actually be used to treat water so that it's clean to drink. It doesn't taste good. I will say, having used chlorination tablets before for water, doesn't taste good, but you are safe and you're not going to die from it. So that's another method that we use. Just depends on where you are. But yeah, I will say that we're extremely blessed to be in STEM and in engineering specifically, where we get to help people all over the world because we've had the education to do so. And I hope this inspires you guys to want to travel and use some of your STEM knowledge that you've learned in Girls STEM Day all over and help other people. That's about all I have though for today. Any more questions?
Emily, you did a really good job, and thank you for sharing that. We did have a question come through in the chat. Just wondering if there are any resources online that you would know of, written directions, if anyone kind of wanted to try this at home, if you do know of anything.
Yes, I do. There's actually a lot of them because this is a pretty common experiment that people like to work with and do. So if you were to look anything up, I am going to one second. So like this here, a biosand filter. So if I'm going to look up biosand filter build, this will give you a number of resources that you can build a big one or a small one. Some of these are like real ones that people are going to use in their houses. But if you look up, I bet, I should say experiment, okay, I can't spell. I saw one. If you want, I can find a better resource, like a specific one that I used, and I can send it out. But there are a lot of experiments and instructables online that will show you how to do this. I just don't have a specific link on hand.
Okay, thank you for sharing. That'll be helpful.
Yeah. Well, that's all from me. So if you guys need anything else, or can I leave the meeting?
You're good. Thank you so much, Emily. That was great.
Sorry.
Thank you all for coming.
Thank you guys again.
Thank you, Emily.
That was really cool. I was really curious.
Yeah, it is pretty cool, isn't it?
Thank you all for coming. We'll see you tomorrow. Bye.
Bye, everybody.
Bye.
Bye. Thank you.
Bye. Bye.
Thank you.
Bye, guys. Thank you for coming.
This was very fun.
You're
Thank you.
welcome.
You're welcome. Thank you for coming.
All right, put them in the waiting room. That was
I
good.
thought that went so well. I thought that was